Introduction. The process of finding derivatives of a function is called differentiation in calculus. A derivative is the rate of change of function with respect to another quantity. The laws of differential calculus were laid by Sir Isaac Newton. The principles of limits and derivatives are used in many disciplines of science. Differentiation and integrations from the from the major concepts of calculus. Stationary points of a curve. A stationary point of a function f(x) is a point where the derivative of f(x) is equals to 0. These points are called stationary because at these points the function is neither increasing nor decreasing. Graphically, that corresponds to points on the graph of f(x) where the tangent to the curve is a horizontal line. As you can see, there are two graphs which shows where the tangent to the curve is an horizontal line. Thank you.
Example 1. Given the function divided by the equation y equal to x squared minus 4x plus 5. Find the coordinates of any stationary points. First step, find the dy dx. We need to move the power of the x to the front of the s. Then we keep anything related to s and remove anything unrelated to the s. Second step, we need to find the s. We need to move negative 4 to the other side. Then we just divide it with number 2 from the s. At this stage, you can state that the curve y equal to x power of 2 minus 4x plus 5 has one stationary point whose x coordinates is s equal to 2. Step 3. Calculate the stationary points y coordinate. To do this, we replace x by 2 in the curve equations of y equal to x power of 2 minus 4x plus 5. X equals to 2 power of 2 same as 4, and minus 4 times 2 equals to minus 8 and plus 5. And after that, after the calculation, you get y equal to 1. So the stationary point has y coordinate y equal to 1. We can therefore state that the curve y equal to x power of 2 minus 4x plus 5 has one stationary point with coordinates which is 2, 1. This result is confirmed using our graphical calculator and looking at the curve y equal to x power of 2 minus 4x plus 5. As you can see, this is the graph. We can see quite clearly that the curve has a global minimum point which is a stationary point at 2, 1.
Okay, so for stationary point, the question goes like find the coordinate of the stationary point of the graph. The given equation y equals to x to the power of 3 x cubed negative 3x squared negative 24x. For step 1, find dy over dx. Using the power rule for differentiation, we find dy over dx equals to 3x squared negative 6x negative 24. Step 2, solve the equation dy over dx equals to 0. Since dy over dx equals to 3x squared negative 6x negative 24, we need to solve the quadratic equation. Dx. So 3x squared negative 6x negative 24 equals to 0. We have to minimize them. Then we get x squared negative 2x negative negative 3x negative 3x negative 8 equals to 0. So using the quadratic equation in the calculator, we got x negative 4 bracket, first bracket, for the second bracket x negative x plus 2. Then we will get x1 equals to 4, x2 equals to negative 2. Step 3, calculate stationary points y coordinate. When x equal to 4, with replacing x by 4 in the equation given, we will get the answer. So y equals to bracket 4 to the power of 3 negative 3 bracket 4 square negative 24 bracket 4, and the answer negative 8t. So the function has a stationary point at negative 4 comma negative 8t. When x equals to negative 2, replacing x by negative 2 in the equation given. So y equals to negative 2 bracket to the power of 3 negative 3 bracket negative 2 negative 2 to the power of negative 2 to the power of 3 negative 24 bracket negative 2. So the answer we will get 28. So the function has a stationary point at negative 2 comma 28. Assalamualaikum warahmatullahi wabarakatuh. That's all from me.
The rate of change. The rate of change tells us how something is speeding up or slowing down. It's crucial for understanding how things evolve over time or space, helping us make predictions and optimize processes in many areas like engineering and economics. It's a key concept across different fields, giving us valuable insights into how things work and how to.
Some relationships between two quantities or variables are so complicated that we sometimes introduce a third quantity or variable in order to make things easier to handle. In mathematics, this third quantity is called a parameter. Instead of one equation relating, say, x and y, we have two equations, one relating x with the parameter and one relating y with the parameter. In this unit, we will give examples of curves which are defined in this way, and explain how their rates of change can be found using parametric differentiation. If we look at this example, suppose we wish to find dy over dx when x equals to t cubed minus t and y equals to 4 minus t squared. So we take out the x and y, x equals to t cubed minus t, y equals to 4 minus t squared. And then we look here, the t is being used as the parameter. Dx differentiate over t dt equals to 3t cube 3t square minus 1, and dy over dt equals to negative 2t. From using the chaining rule, we have dy over dx equals to dy dt over dx dt. So the answer we will get negative 2t over 3t square minus 1.
Hi, my name is Amirul, and now I'm gonna show another example of rate of change. If y equals fx, dy per dx can sometimes be interpreted as the rate at which y is changing with respect is x. If y increases as x increase, dy per dx more than 0, while if y decreases as x increase, dy per dx below 0. Example of question is, the radius of a circle is increasing at the rate of 0.01 cm square. Find the rate at which area is increasing when the radius of the circle is 5 cm. For the solution, there are there are three steps to do. We need to use all of the information from the question. Firstly, let A be C the area of the circle of radius r. That means we need to calculate the area of the circle of the radius. A equals pi r square, and then we get the A per dr equals 2 pi r. Next, by using the chain rule, we need to use this formula. The A per dt equals the A per dr times dr per dt, and then we get dt per dr per dt equals 0.01 cm square. Lastly, we need to find the radius and use all of the information we got and from the answer. When r equals 5 cm, the A per dt equals 2 pi times 5 times 0.01. After that, we get 0 pi times 0.01. And finally, we can get the answer, and that the answer is 0.3142 cm square.
In conclusion, calculus revolves around the core concept of differentiation, which serves as the cornerstone enabling precise examination of function behavior. Through differentiation, we gain the ability to scrutinize rates of change, pinpoint critical points, and address optimization challenges. Spanning from fundamental differentiation rule to advanced methods like implicit and partial differentiation, this mathematical tool equips us to confront a diverse range of real-world issues in physics, engineering, economics, and beyond. Proficiency proficiency in differentiation grant us a robust framework for comprehending and manipulating functions, opening avenues for profound insight and inventive solutions in calculus and its practical application. This is the reference that we use. That's all from us. Thank you very much.